Hello, it's your machine shop math guy, and today I want to go into how you can find the inscribed square inside a circle, or vice versa, to find the circle that you need for an inscribed square. Now, the first time I ever did this was when I was making a check key for machine shop class, probably back in junior year of high school, and it was very interesting because I first knew about the Pythagorean theorem, which would give me the dimensions I need, and finding from, say, an inscribed circle to find the square within, and basically came up with my answer. But when I got into trigonometry years later and knew about the sine of a 45-degree angle, I found a better way. And then years later, when I was looking in, say, a copy of Industrial Machinery's Handbook, I found out that this is the better way to do it, is by learning two constants, and it's all coming through from the sine of a 45-degree angle. Now, let's get into, say, the chuck key situation. Say you want to make a chuck key, and you have to make that square, which is inside a circle, because you're turning it on the lathe, and you don't know what size circle you need to get the inscribed square. Well, here's how you do it. You first figure that your inside square is going to be a smaller value than, say, the circle that surrounds it. That's obvious. Here's the mathematics behind it. If you have your inscribed square that you know, the dimension of it, say you want to make a chuck key that's a 1/2 inch square. All you have to do is take that 1/2 inch square that you know what it is and multiply it by the value 1.4142. That's going to give you the diameter of your circle that you need for that 1/2 inch square. Now, conversely, if you have a circle, but you want to find the dimension of the side inside that circle, all you do is take the diameter of the circle and multiply it by 0.7071. And that's going to give you the inside square. Now, once you do that, you better be realizing by just looking at it that once you get that dimension, you have to take the difference of what this circle is as opposed to what this square is. And once you get that difference, you better be cutting that difference in half, because if you don't, you start taking all that distance off of all four sides, you're going to get a much smaller square than you bargained for, and it won't be right. As my father would say, you're going to be messed up like Hogan's goat. So once you get that difference between the two dimensions, cut it in half, and then take that half off of all four sides. Then you'll have the right inscribed square inside your circle. I hope this made sense for you, but here's the mathematics of it. And just remember, take it slow and go back. If you need to have some help with it, go to a Machinery's Handbook. You'll find the same situation that I talked about, and it'll tell you what you need to do to get the value of the distance between an inside square inside a circle. It's all there, and all you have to do is follow it. You can do this for any size square within any size circle, and it'll work because the constants are correct. This is your Machine Shop Math Guy signing off.